Question 15 is about an experiment that we've done before in class. It's to do with determining the acceleration due to free fall. We're told in the beginning of the question that the student uses a small steel ball. So small is given because that indicates there'll be a small amount of drag because the area of the ball is small. And because it's steel, it'll be dense. So the weight of the ball will be large compared to the drag force. So effectively the drag force is insignificant in this experiment. The table of data has got data recorded to 3 decimal places for both the height and the time. And that's important because when you choose the equipment you're going to use to measure those quantities, you need to make sure that they are sensible for those requirements. And I've highlighted the space over here for the data that needs to be substituted later when you get to that part of the question. So we just moved down to part A. The first one is a 4 marker, and most of you should be quite able to get all 4 marks, but they can be easily lost if you're not sure about what the question's really asking. It's asking you to describe, so in other words, use the correct terminology on how you would measure values for h, the height, and t, the time. But you must remember that you've got to use appropriate equipment. So as I said before, 3 decimal places for both height and time. Those 2 statements about what you would use would be worth 2 of the 4 marks. And you just need to write clear statements, as it indicates there, to show how you would word that in the answer. The next 2 marks are more to do with the detail of the timing, because it's important that you can show that you know how the timing will be for the distances that you've measured. So for example, how will you start the timing, how will you stop it, and what will you connect your timer to in order to record the data. So you should be able to get 4 marks without too much trouble there, but try to give your statements in nice straightforward sentences. To measure h, he would use a, and then whatever the equipment is, and the same for the other quantity as well. Part B says complete the table for the missing value. It's just a case of squaring 0.430 and making sure that your answer is rounded to 3 decimal places there. Part C then goes on to the graph of t squared against h. I haven't explained why it's t squared against h, but we get to that bit later. And because you've got the data in the table above, you can plot the missing data that you've now calculated the value of t squared for, and then draw a line of best fit. Now importantly, when you let's start with the data point, you need to make sure that your data point is to within a half of the smallest division on the page. So you can see where I've plotted it there. It can only be half of a small division to the left or right or above or below. So you must be careful. Use a pencil and you can obviously rub that out if you need to. Same is true with the line of best fit. I've shown there one possible line that you could have drawn. Probably you would get many different answers because it's your judgment that's involved. But when you put your line of best fit in, choose 2 points where 2 grid lines intersect as far apart as possible, so you've got a nice large triangle, and then label the points that you're going to use for your gradient, and once you've done that you can then calculate the gradient from delta y over delta x. In this case I got 0.213, which is just within the boundary that was acceptable for this question. Okay, so on to the next part of the question, and here we're asked to use an equation of motion, constant acceleration, to show that this expression is correct. So what could we use? Well, we've only got a limited number of supervat equations, and the only one with t squared in it is s equals ut plus a half at squared. you need to show that S is going to be representing H, A is representing G, and then rearrange that equation with U equal to 0, because the ball can be released from rest and allowed to fall freely. Use the answer from CII, that's the gradient that we calculated. So how do we get the value of G? Well, we look at our equation here, which is y equals mx. So this is the equation of a straight line, and this is our gradient. So the value we got, 0.213, is equal to 2 upon G. Rearrange that for G, and then you've got your final value.